I'd like to accomplish, I would like us to, I want to finish talking about our, I started last time basically giving the PowerPoint that the students in this class put together and gave last year. You can get a sense of what that talk looks like, what the background is. It's very good, it's a good foundation for the arsenic. And then for the last half of the class, I want to talk about what it's going to take to get this project off the moving. Specifically, what we need is to agree upon a form that will go out with, go at lunch on one of these days, maybe even today, probably Tuesday. Announce to the school, if you have well water, please give us a sample, and we'll initial cases that have high enough arsenic and meet the right criteria for us collecting the data for the trade class. So I'll finish with this talk. Sure, yes, but that also get the document up and get our. There's a lot to this. So if this project goes the way that it's going to be a bunch number of expecting to go through hopefully 30 bags. That is tricky. It's all that data, so it doesn't. You have to start proper study. Delayed till Tuesday. That could also give us the and then, but certainly next Tuesday, I would like by then the public start tracking and collecting data, and I want to start actually diving in. All right, so for those who missed last time the video of what I was talking about in the last class period, it's a Google Classroom right now. Thing is that there's a high level of arsenic in well water in Maine. There's this recent round, last year's sampling was important for the area because the first time that 50% that were collected and tested from the county here. Only really 2 places in the state that have had to together with have a good idea. Academy of all the high school sample data set. Our high school has by far the widest geographic area of municipal strength. Three types of wells, and the question is based on well depth, and it turns out it is. There was this thing, there are three types of wells: drilled wells, driven wells, and dug wells. Drilled wells are 100 feet and over, driven wells are between 30 and 100 feet, and dug wells are between 30 feet. The drilled wells, unsurprisingly, have very high arsenic because they're drilling the rock that has arsenic. The driven wells, there's virtually no arsenic problem. And then, but dug wells, there's this spike in arsenic here, and the hypothesis was that it's from anthropogenic. The driven wells, that's geologic, it's stone, but anthropogenic stuff on the surface. And what were the sources? In Maine was herbicide use and road salt are really good. But all right, so the next question that group of students asked was, if the dug wells represent surface water, which can be affected by these anthropogenic sources of water, of arsenic, like pesticides, does the arsenic in dug wells correlate with lead, right? Because the pesticide is lead arsenic, the pesticide controlled it. Does this come from historic pesticides? So here are a picture of what a dug well may be. In an apple orchard, you maybe dug a well so that you could pump water out of it. And there are not an insignificant number of people who actually get their water comes out of type well. All right, so this is a study that is about a decade old now, and it's showing that that lead and arsenic are different and travel different. They have different solubilities, and they have just different properties. So it's not a straightforward. It's not really straightforward comparison. So 65% of the initial concentration of arsenic is transported in the stream, whereas only 12% of the lead. Right? So there was this study where they spiked the stream with lead arsenic, and then they looked to see how much of it traveled how far down. 65% the arsenic, but only 12%. So lead is a little bit sticky. Yeah, so if you can see here, this is the concentration, and this is distance. And as we go up in distance from the mouth of the tributary, the arsenic is a consistently higher value than the lead. So this is actual data from our data set, and we're looking at arsenic levels versus lead levels. All right, and if we were going to be seeing signals that were due to lead arsenic, right? Lead arsenic, and we already know that the signal is not, lead actually is not a very good measure, but we are looking in the data set to see if lead was traveling with it. And if lead and arsenic was correlated, you'd see a data line out here, right? You'd see points in this direction. But what this is telling us is that arsenic levels that go up, these arsenic levels don't have very high lead. If they did, they'd be over here. So if you have high arsenic, in general, you don't really have high lead. And if you have high lead, in general, you don't have very high arsenic. So they're not really correlated. Except in Waterville, here, Waterville schools, 3 of their samples turned up to have pretty high levels of salt, pretty high levels of lead and arsenic. And the question is, to get the lead to move, to have a high, to show up in the water, what is doing that? There's got to be some chemistry behind that. And the question is this mediated by road salt in Waterville? Waterville dumps quite a bit of, and road salt could displace the arsenic and the lead that would be stuck to the dirt in the topsoil. It could move it out of the dirt. The salt could wash it. And then the lead and the arsenic in the water. Is this what's going on here? And you'll notice that these values actually are above the EPA limit for arsenic. So it's not. So and this was in dug wells. There were 3 dug wells associated with, and we were just looking in the dug wells, right? Surface water. There turns out there was one, looking across all wells, there was one well in Blue Hill that had super wicked high arsenic. But it wasn't a dug well. This was probably driven. Not drilled. All right. So what do we know about road salt? How does this work? And this is how salt dispersion works in the environment. Some road salt comes on. Maybe there's a road nearby. I couldn't find a good picture that had a road and a stream next to each other in the wintertime, but you get the idea. There's plenty of them. I should take one. Great picture at the Mayflower Hill as it goes up into Colby there. The Arb Stream passes beneath that road. And my wife, who's an aquatic ecologist, she measures conductance. It shows how well the water conducts electricity, but it's also a proxy measure of salt concentration. It's always way. The road is right there. So anyways, salt comes into the soil, and it displaces various metal ions, metal cations, iron, and dissolved organic carbon, both on the topsoil and in the ground. And then that enters the surface water, goes into streams, or it can go into an aquifer that a dug well. Very, very. So this is just a bunch of facts for around road salt use in the state of Maine. So Maine spreads 500,000 tons of salt on its roads every year. It's amazingly 4 times the combined mass of all 1.3 million residents. So for every pound of body weight, there are 4 pounds for every road. That is the real cost of you living in the state. It's that much salt, which is an environmental gets dumped. Waterville had 1,500 tons, so that's 3 million pounds or whatever on 280 lane miles. So that's 5.3 tons per. It's a lot of. So I just said, 3 million pounds. How many pounds of humans are in Waterville? Let's say that 200. Let's say the average human in Waterville certainly. And 100 is so 200 pounds, 3 million pounds. Let's just say every person water easier. That's and that's the that's about the dump free. A lot of anyways, the takeaway is this is a legitimate concern for a lot of reasons. Road salt is bad, road grease, but just one that no department of ever going to mention about the problem of road salt. One that they will never mention is arsenic. So the other thing that you guys did, how bad? Bladder cancer, cognitive deficit, and so this is again just sort of the mechanism of it. Here's the road. Here is you get no road salt. There's a little bit of arsenic that's in the topsoil in this organic horizon. It's just topsoil. And that can come from, maybe it's been there since the 50s when they were spraying this shit all over the place on these apple orchards. And a little bit gets into this leachate zone and a little bit gets into the deeper well. However, when there's road salt present, it like washes it out. Cation, metal, arsenic, metal in this topsoil, that metal cation pushed out by the salt. So now that arsenic is dissolved a little bit more easily, and sure. So one of the things, so this is another study that Trinity dug out, looking at showing that arsenic can be displaced by road salt. And it's showing that it's not just salt, or it's not just sodium that happens to be high, but it's sodium chloride. And so what we see here is as sodium goes up, arsenic goes up in these water samples, right, for both sodium and chloride. But what's really important here is we have sodium chloride molar ratio, right? This molar ratio of sodium and chloride. So it's not just how do we know whether these two are correlated? Is it sodium chloride or is it some other source of sodium? Where's the chloride? What's the counteranion to chloride? Well, we're showing here that arsenic goes up. Again, this is arsenic level when the sodium chloride ratio in that sample is at 1 to 1. So it is actually sodium chloride. It is road salt that is driving the arsenic out of the topsoil. So this is like smoking. You guys following me? Have I lost anybody? The question. What about road salt? The answer is can't tell from the data set, unfortunately, because the SEPA data set does not have, there aren't conductance values. We don't have sodium chloride ratios. We don't have chloride concentration from the data set. That we're not testing for sodium and chloride in the water samples. We should be. And they didn't measure conductance. Water softening. People who have water softener can make it complicated because sodium chloride out in there. So that can make the data harder. So you might be able to find correlations, spatial correlations. This is a cluster of high arsenic, these dug wells right in this location, right next to a road that gets a huge amount of salt, road salt. So if you went to the Maine Department of Transportation road salt data and you looked at the hydrology maps and stuff, you may be able to correlate road salting and level of. So that data we may be able to bring a lot of sources of information together and have indirect correlations, not causation. If you could get the sodium and chloride measured as analytes, you could get a causative relation. Amazing. But there's a lot that we do know. So this is an analysis that Trinity and Callie did on the data set, which is phenomenal. Phenomenal bit of work that they did here in this data set. Out of the 1,100 samples that were collected, 400 wells, or 37%, had one of 14 different heavy metals that were above the EPA for safe. So this is saying that higher than 1 in 3. This is about like 2 in 5 wells in the state of Maine. Those people are drinking something that they shouldn't be. And it's like stuff you've never even really heard of that much, like beryllium or chromium. A lot of wells had too much manganese. So here, this is the total wells, the whole data set. This is the number just from Maine. So all of New England, there were 1,100. In Maine, there were 600 wells tested, and Kennebec and Somerset counties had only 100 wells that were actually tested. The thing that is striking about this is arsenic across all of New England, across all of Maine, and just in Kennebec County is all about 20%, anywhere from 18 up to 21%. It's remarkably consistent. Arsenic is a problem throughout all of New England. It's definitely a problem. This number, so previous to this, like when this woman that you will eventually, Disney, who is the principal investigator who wrote she's at the MDI Biological. I'm going there this weekend to talk at the conference. She gives her initial talk. She talks about how the value is about 10% in the state of Maine. Well, 10% of them, 1 in 10. And we blew her hair back at the conference last year in the spring when my girls here showed this data. And that actually, that number is 3 times, the actual number is about, 2 times higher than what you've actually been reporting of. There's some other things, like manganese is a chronic toxin. It's bad for you. Freaking uranium. There were 4 wells in the state of Maine, in Kennebec County, that had uranium, radioactive uranium, the water above. This is a problem. It is a problem that is not. This isn't just some abstruse problem like God, there's a war in Yemen. Like that, right? These things that don't seem like they're affecting your life or whatever. This is the water that you and your family and your friends and your neighbors are drinking. And it has real health consequences. It's like you can't, I couldn't imagine coming up with a topic that is more relevant to everyone. Everyone, not every, but like everybody's drinking. All right. So I don't know. The students wanted to look at uranium because that was pretty wild, and uranium actually does correlate with arsenic a little bit. That's surprising. MAA only actually had one sample with analytes outside of the EPA safe drinking water range, and that was so. This was Kennebec County, right? All these numbers, and actually there was only we only last year Snow Pond was only able to get 18. That's all that we and this is what I determined to have you guys get past. I only had 4 students last year, and a few of them in it. It's a bigger class this year. I want a lot more. So out of the 18 samples that were collected, only one of them actually had any well that are batteries. But we never tested the school's water. The school I know, unbelievably, we never tested. But it is well water, so I think we should be testing the school's water. Why not? Makes sense. That's at least one we can test quite easily. So, anyways, yeah, I would like to get at least 30 or 40 wells in school that we tested, and I would like to identify people of them that we would like to throughout the year, and then I would like to work with some of the other schools like Waterville. They have some wells. Like the thing about the Waterville, the guy that sang that, I don't think had like their teacher. He didn't quite have the standing and drive about getting engaged. How you ask, but we're getting them, and I want to look through their data, identify wells in their data set, and get them to. What I want to see is like low arsenic in the fall, high arsenic during snowfall, or like lagging snowfall. There's been like heavy road salting, melt, and see if there's like some sort of signal that correlates with seasonal variability. Low in the fall, high in the winter or maybe spring. That's uranium. Again, these would be wells that correlated arsenic. All right, so then the students want to know, does domestic water filtering help? And yes, it does help. Look at here. This is New England, and untreated domestic arsenic is super high in New England. So if you have a well that, on average, that well is going to have high arsenic. However, if you treat it, then it goes down. And public levels, you'll notice on all of these, except in the southeast, in general, public levels are pretty low, and that's because the EPA is sitting up. Yeah, the West is messed up by Nevada, right? So the other thing about one of the things in California, this is a broader health the way water utilities are regulated in California. It seems like people think, oh, California. But in reality, California is also one of the unequal states. So there are super rich communities, and there are very marginalized. It tends to be that and so in every community has their sort of like water, maybe, I don't know. A lot of talk about how America's aging infrastructure. We're at least 25 years overhaul. And you say you're talking about various basic. We all share. America's super old because we were one of the first to implement the kind of wide-scale modern infrastructure that we had back in the New Deal era during FDR, back in the 30s. Depression. But that was freaking 80, 90 years ago. And that stuff crumbles. It needs to be. They haven't been. So, particularly in the West, there is a real problem with. There's a real problem. And there's socioeconomic. So this is just looking at through the SEPA data set, the main-based data set for New England. Looking at like the filtration type. A lot of people didn't know whether their water was filtered or not. No, the water was. And no data available. No filtration and some form of filtration. What you notice here is that some form of filtration is not that much better than no filtration at all on average. The mean here is just below the EPA limit, and it is not that much lower than that. It's 1 part per billion and 1.5 parts per billion lower for people who do have filters. What the hell does that mean? What do you think? Why did no filter not do that much worse than having a? Anybody filter the water? Yeah. They're not filtered. What else? Does anybody have a? Sure, whatever. It was to say. Have you ever looked at it? What have you noticed? What is the? Okay, good. The light. So that's good. That's a nice filter. Not every filter has that. A lot of times people, they're just not maintaining their filter. The filter's been on there for 10 years. It's probably doing nothing. In fact, maybe even worse. With time, filters supercharged filters be discharged. Yeah, you gotta keep up with filtering. It's not magical. It's not Hogwarts. Those filters magically. They are in the filter. All that nasty stuff that has gotten pulled out of your water. So like old water filter is super quite high toxin, particularly. So sink-mounted filters perform particularly poorly in this comparison. Yeah. The mean is 33. The median is the median value. Even just the median value is definitely. So these are people who have a sink-mounted filter. They think it's protecting them, and on average, it's not. They're drinking water that's worse than the EPA would have them. On average, right? The mean is 33, which is over three times the EPA value. But even the median value, cutting out some of these extremes, the median value is above pretty high. Whole house filters, the mean is pretty high because you have these, and it's actually, all right, that was it. What they were was a pretty good amount for, I don't, I'm working on the entire year with like